Good morning, fellow researchers of International Seminar of Science and Applied Technology. Hopefully, we are all always in a good health and in a good spirit. We would also like to express our gratitude to all of the ISSAT POLBAN committee and also to the reviewers that have selected our abstract and paper. Alright, now we would like to deliver our presentation entitled Smart System-Based Water Quality Measuring Device for Clean Water Availability, or as we call it, ALUKAR. And our team consists of Hendra Jarnika, Yudi Purwanto, Sally Carmila, and M. Farid Rifai. Our presentation will consist of research object, objectives, solution and problem solving, and conclusion. Now, let's start with our presentation. This research was done in a place called Ciarutan Ilir Village in Bogor District. As many as Indonesians usually understand, clear water means clean water. And actually, in many cases, it is wrong, as even clear water contains harmful particles for our body. The village has a very minimum knowledge about the water's condition. It is because the average education rate is also low. It is then affected by the area's geographical conditions, as can be seen on the next slide. This is the documentation of our research at the village. You can see the condition of the village is not quite good. After the observation, discussion with the villagers, and close study together, then we determine our focus and goals, and also the results of our research. The research methodology was done as follows. Starting from observation, data collecting, and literature study, we then made a design for both software and hardware. After that, we insert the C45 logic, doing phase 2 to 4 testing and evaluations, and also doing the documentation with the explanation as follows. Alright, fellow researchers, now we would like to explain a little about the design of our research devices, which we call ALUKAR, or Alat Ukur Kualitas Air, or in English, Water Quality Measuring Device, up until its measuring test phase. The method of making the device along with software and programming language used. The hardware design consists of an Arduino control system that acts as a sense of or controller and performs data processing. The design of the system is presented in the form of block diagram that will help in designing the Android-based water quality monitoring device using Arduino Uno as a data processor, water pH sensor, and LM35 temperature sensor. After the hardware design is complete, the next step is to design the software. Software design is done using Arduino software, which is then downloaded to Arduino Uno. After that, creating an Android application using MIT Inventor software, which is then connected to the Arduino Uno software. The making of software lines program code is done by using the Arduino IDE application version 1.8.1 with a C language that is adjusted to support the overall device performance. So this is the scheme of how our device will be used. On how to make the device. 1. All equipment are arranged according to the provisions and of each component. 2. Design the program source code for temperature, pH, metal content, LCD and GSM module sensors. Each source code is tested to ensure that each component is running well. 3. Each source program code for each sensor, LCD and GSM module is combined into one, which is each sensor code is created in one function. For example, the ALUKAR source code. 4. Design the application flow and database design. After that, creating a web application is tested whether the ALUKAR can send data to the web. So this is the documentation of our project. So now this is the C45 algorithm. From time to time, the data gathered, those which come from the same source but taken in different times, can be concluded. The method used is C45 algorithm. The case study can be seen from the following table. A decision tree will be made based on the cases from the table above to determine the feasibility of the water sample by considering its pH, temperature, and total dissolved solids, or TDS. The solving steps are as follows. Calculating the number of cases for feasible, less feasible, and not feasible decisions, and entropy for all of the cases, which then divided based on the pH, temperature, and TDS attributes. You can see the formula on the presentation slides. B. Calculating the gain for each attribute. The gain value of the pH row is calculated with the following equation. As you can see, the formula is on the presentation slide. From the table above, it can be understood that the attribute with the highest gain is the TDS with 1.32. So the TDS will be the root node. There are two attributes value from GPT, for example, suggested and unsuggested, though we need to count the suggested value only. From the table, it can be understood that the attribute with the highest gain is pH with 1.14. So then the pH will be the branch node from the suggested attribute. You can see the scheme or the presentation slide. This is the result of the test. As you can see, when we turn on the device, user connecting the device to the power bank and the device is on. And it will show the sensors measurement data, and then user put the sensor to the tested water. The data is presented on the LCD measurement data. And then after that, send the data to the web server. User insert the SIM card, turn on the ALUKAR, and put the sensor to the water. User insert the SIM card, turn on ALUKAR, and does not put the sensor. The result is 2. 1. The device is on, the data appears on the cell phone. Or 2. The device is on, then the data appears as 0. Both are valid. So this is the result of the test. As you can see on the table, it's all valid. This is the interface of the application of ALUKAR. So the result of the test shows that all of the process is valid. This is the dashboard. And conclusion. From the process of making and testing ALUKAR, it can be concluded that 1. ALUKAR can be a solution for the community to be able to know the quality of the water they will use. 2. ALUKAR, with its web database system, can predict water quality in certain seasons or time in an area. 3. ALUKAR is portable, so it can reach remote water sources with a high degree of accuracy. And 4. The development of ALUKAR can be done by adding several other water quality inspections, such as mineral content, chemical content, and etc. And by adding water quality matches with their usages on the web. This is our reference that we use. And I guess that's enough for today's presentation. Hopefully all of our fellow researchers can grasp and recognize our research. Thank you for your attention and good afternoon.